Hello everyone, today I'll be doing an experiment about cold water and hot water. For this simple experiment, we will need a balloon, a plastic water bottle, also cold water and hot water. The purpose of this experiment is to observe when the bottle is placed in hot water, the balloon will inflate, and when the bottle is placed in cold water, the balloon will deflate. And after this experiment, I will be answering some questions about this experiment. Now we can move on to doing the experiment. Firstly, we will put the water bottle inside the hot water. As we can see that instantly the balloon is inflated. Now we'll put it in cold water. And we can see that the balloon instantly deflates. Moving the bottle quickly between hot and cold water shows immediate inflation and deflation of the balloon. Now I will be answering the questions about this experiment. The first question is, why does the balloon inflate when the bottle is in hot water? When the bottle is placed in hot water, the air inside the balloon absorbs heat. This causes air molecules to move fast and spread out, increasing the pressure inside the bottle. This increased pressure pushes into the air balloon and it's inflating it. Now the second question is, why does the balloon deflate when the bottle is placed in hot water? When the bottle is moved to cold water, the air inside cools down. Cooler air molecules move slower and contract, reducing the pressure inside the bottle. This creates a partial vacuum pulling into balloon inward and causing it to deflate. Moving on to the third question. What role does the temperature of air play in this experiment? Temperature directly affects the movement and spacing in air molecules. Warm air expands, taking up more space and increasing pressure, while cold air contracts, moving slower and taking up less space, and this causes the decrease in the pressure. Question number 4 is, how does the bottle act as a medium in this experiment? The bottle contains air, allowing it to be influenced by the temperature of the surrounding water. It serves as a sealed environment where changes in air, temperature, and pressure can affect the balloon. Question number 5 is, what real-life applications can this experiment demonstrate? This experiment illustrates principles of thermodynamics such as expansion and contractions of air with temperature changes. It is similar to how hot air balloons work or how weather patterns form due to the temperature differences in the atmosphere. Sixth question is, what would happen if the balloon did not seal tightly on the bottle? If the balloon isn't sealed tightly, the air inside the bottle would escape when the temperature rises. This would prevent the pressure buildup necessarily to inflate or deflate the balloon, and the experiment will not work as if we want it to work. Question number 7 is, can this experiment work with other containers besides a water bottle? Yes, other containers can also work with like a wider shade, such as glass bottle or jars, as long as they hold air and allow the balloon to seal tightly. However, materials like glass may take longer to transfer heat compared to plastic, affecting the speed of the experiment's results. The last question is, what happens to the balloon if you keep the bottle in hot water for too long? If the bottle remains in hot water for too long, the air inside may expand to its maximum capacity. Once the balloon is fully inflated, it will stop growing unless the material stretches further or bursts. The temperature of the water would eventually stabilize with the surrounding air, ceasing further changes. To conclude and sum up this simple experiment, This experiment effectively demonstrates how temperature changes affect air pressure and volume, using basic materials for an engaging hands-on experiment.